What is the Molecules in Motion curriculum? Molecules in Motion is the 2018 Water Week STEM activity. It has been designed to meet the learning objectives of the 4th grade Common Core and is published under a Creative Commons non-derivative license, which means educators can make copies and share the full curriculum at no cost. But I am getting ahead of myself. Let me introduce the instructor team for this video. My name is Shannon from Thalweg Education, and I will be the narrator for this video. I will be assisted by Monica from Central Utah Water Conservancy District. Central Utah's H2 Joe will also be dropping in to give some helpful hints. Let's start our discussion about molecules in motion with what happens before the activity begins. First, we suggest that you review and practice the curriculum before running it. In particular, it is useful to practice the freezing and sublimation activities to get to know the quirks of your equipment. Also, if you do not already have the Molecules in Motion passport and instruction sheets, I would suggest pausing the video and downloading them from the links below so that you can easily follow along. Once you are comfortable with the curriculum, you will need to purchase the supplies to run the activities for a group. Dry ice can be particularly difficult to purchase in some communities, so we suggest that you contact your local grocery store before the day of the activity to make sure that it's in stock. Finally, 2 hours before the activity, put sealed bottles of water into the freezer. This will allow the water to supercool for the freezing demonstration. Now that we have covered what you do before the activity, let's jump into the experiments. Throughout the Molecules in Motion activity, youth will be making their way through the water cycle. Their first experiment will take water from a solid to a liquid through the process of melting. For this experiment, you will need disposable cups, large ice cubes, salt, sugar, hot water, cold water, and room temperature water. The melting experiment is the simplest activity of the day. For it, you will put an ice cube into each cup and then add the treatments such as salt or water. The youth will then observe to see which ice cube melts fastest. After completing each activity, it is important to take a moment and talk to the youth about what they have learned. One concept that you can discuss relating to the melting experiment is what is a control. Once the discussion is complete, we can move on to the next experiment, which is transpiration. Transpiration is the process where liquid water is turned into a gas with the help of a plant. It is a byproduct of photosynthesis. For the transpiration experiment, you will need water, coffee filters, washable markers, cups, and paper plates. The first step in the transpiration experiment is to take your washable marker and draw a dot in the middle of your coffee filter. You can use whatever color marker you'd like. Then you will begin to fold your filter into the shape of a wedge. Briefly dip the filter into the water after you have folded it into a wedge. As the filter dries, you will be able to unfold it and see a pattern. Have the youth participants record their observations in their passport. If some of your youth want to learn more about transpiration, A great concept to discuss is capillary action and how, under the right conditions, the shape of water allows it to defy gravity. Time to move on to condensation. Condensation occurs when water vapor is cooled down, allowing it to change from a gas to a liquid. For this activity, you will need a glass mason jar, a sponge, ice, water, a microwave-safe bowl, and a microwave. Start this activity by putting a wet sponge that has been heated in the microwave inside the glass jar. Put the lid on the jar and put ice on the lid. Then watch as a cloud quickly forms inside the jar. The condensation activity is a great time to discuss why scientists have special terms for things they observe. For example, water vapor versus steam. It is time to pull the water bottles out of the freezer because in this activity we will be turning liquid water to ice. For this activity you will need bottled water, thermometers, and a freezer. You have to move very carefully when you pull the supercooled water out of the freezer. Any jolt can cause it to crystallize. When you are ready to allow the youth to observe the freezing process, give the bottle a quick bang on the table. As you pass the frozen water bottles around for the youth to feel, it is a great time to discuss real-world applications for supercooling. Time for the last activity, sublimation. Sublimation occurs when a solid becomes a gas, skipping the liquid stage. Sublimation is regularly observed in cold climates, such as the poles, high mountains, and outer space. For the sublimation activity, you will need a bowl with a lip, dish soap, warm water, heavy gloves, dry ice, and a strip of cloth. Start by putting the dry ice and warm water in the bowl. Then soak the strip of cloth in soapy water and run the cloth along the outside rim of the bowl. Then pull the cloth across the lip to create the bubble. As we finish up the last activity, this is a great opportunity to put the whole water cycle together and discuss with the youth where humans fit within the water cycle. And that finishes up the activity. As you are wrapping things up, remember to remind your youth about where they get their water. Introduce them to additional science resources such as books, and encourage the participants to continue to experiment. Good luck running your activity, and have fun!